Quoting for custom part manufacturers is a real challenge. You have to make sense out of the 3D CAD models, the engineering drawings, figure out what a part will cost to make, and then decide how you should price it. And you have to do all of that quickly. Naturally, estimators are asking, how can AI help? In response, we're seeing a lot of content being posted making bold claims about AI. And we here at Paperless Parts would like to walk through what's actually possible today and the approach we've taken to create manufacturing aware AI to make quoting easier without sacrificing speed or accuracy. I'm Scott Sawyer, co founder and chief scientist here at Paperless Parts. My job is to bring AI capabilities into our product to help you automate the annoying tasks you're eager to stop doing. Short agenda for you today. First, we'll look at one possible way to apply state-of-the-art AI technology to estimation. Then we'll talk about our approach at Paperless. And finally, we'll dive in to some of the things that we've built and how we've gotten as far as we've gotten. So to get started, let's talk about one way we're seeing folks use top-of-the-line AI models to quote parts. And that's vibe quoting. So in software engineering, there's a thing called vibe coding, where you prompt the AI models with a description of what you're trying to build. You have it generate the code for you. You check whether the software seems to do what you want, and you never really bother to review what code it wrote and how it did it. So vibe coding is a great way to build a quick demo, but today it's not really a viable option for writing robust, secure, high-quality enterprise software. So let's suppose instead of vibe coding, you want to do vibe quoting. How might that work? Well, let's imagine quote GPT. And we can actually do better than imagine it. I tried it out for you. Big disclaimer, don't do this with your customers' data unless you really understand your NDAs and any compliance requirements like DFARS or CMMC. So what I did is I created a custom GPT inside of ChatGPT. And here's in the example simple sheet metal assembly I uploaded. So I have a blueprint here. I also took some screenshots of the 3D model since ChatGPT doesn't natively accept CAD files. Then I wrote a detailed prompt describing to ChatGPT exactly how I wanted it to generate a quote for my part. Then I hit enter, and it started thinking. It actually thought for quite a while. It worked for about 10 minutes on this quote, and then it returned some truly interesting information. So let's talk about what I got out of this system. ChatGPT presented a lot of good information about this assembly. So these are direct quotes from the LLM in response to this prompt and the data I presented it. So first, it said, this is not a single part. It's a two-piece sheet metal enclosure assembly with installed hardware. Yes, right on. That's correct. It found and understood the BOM table without specific prompting around that. So that's fantastic. Next, it said, it's 5052 type sheet suitable for bending. The exact alloy/temper is not fully explicit, so this is an estimating assumption. That's not bad. So it found AMS 4016 and it translated that to aluminum 5052. I think it could have made a stronger statement than this, but it's not wrong. Next, it said from the detail sheet and your CAD screenshots, this is a U-shaped cover with vent slots, mounting captive screw features, and a few small pierced holes. So this is arguably the coolest thing it did. This is a really good description of the part, which is amazing because a lot of those words are not present in the blueprint. Super cool. Then it said there's one non-90 degree formed feature called out at 36.87 degrees. The 36.87 degree form feature is fine, but it adds setup sensitivity. Ooh, no, this is actually the first thing it got distinctly wrong. So that is not a non-90 degree formed feature. Although that angle call out is present, this is actually just a diagonal cut on the laser. So that's not quite right. And it could have the wrong impact on the costing for this part. Okay, so that's very interesting. I then asked it to make a bunch of assumptions about shop rates and markups, and it went ahead and quoted a price for quantity 1 and quantity 10. How did it do? Well, what do you think? So about $300 for one, about $100 each for quantity 10. I was tempted to actually reach out to some of our estimating customers to quote this, did not want to waste their time. However, I don't mind wasting my own team's time. So I asked around the office and I said, what should this part really cost? Now, they had no idea I was going to include their photos and answers in this talk, but too bad. So the answers were all over the place. Luke and Connor were fairly aligned with ChatGPT. Connor and Meg were probably thinking prototype quantities at this $400 and $500 mark, and just the general pain factor of dealing with really small quantities for parts. And then Alex here was thinking more production scale. So let's grade now ChatGPT against our smart humans. So both estimators, meaning human and quote GPT, uh, nailed quote setup. Stuff like part number, material, finish, bill of materials, and proposing reasonable routing. Everyone was fine at that. I didn't give ChatGPT a real list of work centers or anything like that, but it uh, qualitatively understood what the manufacturing steps would be. But now suppose we're moving into non-trivial quantities. These other things really start to matter. So, for example, let's talk about laser cut length. The human estimator, using paperless parts for assistance, would have correctly come up with 155.5 inches of quote length. ChatGPT, looking at this, predicted 128 inches. So that was 18% off and an underestimate. Definitely not perfect. As far as bends, the human estimator, again with paperless parts, correctly gets to 12, which is the correct bend count. ChatGPT sees 8 of those based on the data I gave it. That's a third off. And finally, the unfolded size, paperless parts correctly unfolds it. It's 18.9 by 9.2 inches as a flat pattern. ChatGPT estimated that at 15.2 by 10.4 inches, off by 10%. But more importantly than the 9 to 10% is that if you ordered sheet metal based on that unfolded size, you would be short. So these things, cut length, bends, unfolded size, really start to matter at non-trivial prototype quantities. So what did we just learn? In summary, quote GPT in 2026, it's not integrated with your other tools and workflows, and it doesn't natively accept 3D models. It's possibly not compliant with your NDAs and security or export control requirements. It's kind of slow. It's wrong with a lot of details. In conclusion, it's about as fun and effective as chatting casually with an estimator for a minute. Now, I don't share this to make fun of AI. People love to dunk on AI, but the truth is I use it extensively every day, and I'm way more effective because of it. This is clearly the direction the world is headed in, but that doesn't quite work yet today. Just this concept of vibe quoting, expecting these models to just get everything right at the first shot. So our team has put a lot of attention into tracking what's happening in the AI ecosystem and bringing the best innovations into paperless parse to help you get your job done better. We call this approach Wingman, and these principles are on our website if you want to read more. I'm going to highlight 3 of them. First of all, we're secure and compliant. Paperless parts handle sensitive data, and we want to make sure that you can use our AI features with any data you would upload to the rest of our application. That means our AI features are CMMC compliant and housed within our FedRAMP boundary. Next, our AI features are transparent and human-centered. We make it very clear when information is coming from AI, and we make it very easy to review. And finally, our AI features are measured, tested, and we're always working to improve them. That's all great. What I'd really like to do is dig in and explain how we achieve this and why it's different than, for example, just uploading parts to ChatGPT. To do that, let's make a clear distinction between 2 very different applications of AI technology. On the left, we have generative AI. These are applications that produce new text, images, videos, or audio based on a prompt, like this AI slop clip art of an estimator. To be clear, I'm not saying that generative AI is bad. I use it all the time. I use it to help me improve emails, to write code, even organize my thoughts. Although I do find it interesting that you can usually tell how new someone is to using AI based on how much clip art like this they're generating. On the right, however, we have discriminative AI, which we found to be much more useful with paperless parts. Here we're using some similar underlying technology, but we use it to identify, extract, and interpret information rather than to generate novel, new content. Again, there's nothing wrong with generative AI, but it does have its challenges. And an incomplete list of those challenges are the fact that you can find training data disclosure, including copyright issues. Perhaps that picture of an estimator superhero was problematically close to other superheroes in literature and the world. Generative AI gives you confidently wrong answers quite often. It has lots of general knowledge, but lacks the domain specific details that someone like an estimator would have. It can be expensive, it's usage based, and it's decreasingly subsidized. We saw a lot of these tools get released where the creators of these models were losing money on every request. We're starting to see that less and less the case. And you're finding that the tokens are now more or less um, fully costed, priced to so that those companies don't continue losing money. And people are pretty surprised at how much their AI usage is starting to cost. And finally, generative AI is really hard to benchmark and measure, right? If there's no clear right or wrong answer, how do you know if the models are getting better? There's ways, but it is a challenge. On the other hand, with discriminative AI, we can avoid these challenges but still take advantage of some really advanced technology. This lets you not only detect and extract text like traditional optical character recognition or OCR does, but you can really understand the wider context of what's happening in these documents. So here we can see the model is able to classify things like dimensions, control frames, view captions without confusing them with other text or numbers. And it does it in a really flexible way that can adapt to all the variations we see in real industrial prints. So that's really cool. How does it work? To tell that story, I'd like to walk you through our journey of paperless parts over the last 3 years or so, bringing AI into our product. We've taken a crawl to walk to run approach, adding capabilities gradually over the last few years. And one of the first things we created was a model that had a pretty simple mission. It took a file name, like one of these you see here, the .step or the .pdf, and its only job was to label each character in that file name as part of the part number, part of the revision, or neither. So in our experience, we knew that most buyers put that information in the file name, but there's absolutely no standard for it. Instead of having a software engineer spend lots of time looking at all the different variations that are common and then writing code to parse each common format, this is a really great opportunity for machine learning. And it's also low risk. So you have a model that can just take those file names and automatically infer which parts are relevant for part number and revision. So we started that journey in 2023. We then moved to what we would call a walk the following year in 2024. We focused on making quote setup easier. That's the process of going from an RFQ to a new quote created in paperless parts with the line items and files assigned. One of the challenges is that part buyers include information just written in plain language in the email body. It might say, "Hi, I need a quote of quantity 10, part 1, 2, 3, 4." This is a perfect application for a large language model. Now, we can't just send these emails to public AI models like ChatGPT, um, and that's due to security and compliance issues. But it turns out that Amazon Web Services, which is the government cloud we're built on, offers LLMs inside of their GovCloud FedRAMP environment. So these aren't the latest and greatest models. They tend to lag 6 to 12 months behind state of the art. But LLMs have been good enough to read an RFQ email for a while. So that's exactly what we do. We use a slightly older LLM. We run in a FedRAMP environment, and that ensures that no data presented to it is used to train, or there's no record kept of any of these chats. And this LLM is perfectly able to infer part numbers, quantities, and so on. And we've gotten some really great feedback on this feature. Then last year, we unveiled PDF callout extraction. And this year at our Power User Conference, we announced a significant upgrade of that capability. So for now, we'll just focus on the AI aspect of it. And, when we went from Wingman version 1 in 2025 to Wingman version 2 this year in 26, We actually removed thousands of lines of code doing the detailed extractions, and instead we handed those off to a larger AI model. Now, these solutions certainly have more code around them to get data in and out and do all sorts of different things with these files. But if you look at just the extraction code, we actually have less code in the new model, much more model parameters, and it achieved a huge increase in performance on a internal call-out benchmark we've created to measure our AI capabilities. So AI is advancing at an exponential pace, and that means any model or software solution that's not getting better fast is actually falling behind. So at Paperless Parts, we're able to ride this larger wave of AI improvement by using the frontier models to design systems, implement code, train and fine tune models, integrate that all into an application, and that lets us keep pace with the larger technology. And this has translated into real results. So in the 11 months between our release of Wingman 1 and Wingman 2 for document analysis, we were able to improve extraction performance by 14 times. So in summary, chatbots and agents are powerful, but they can be wrong and non-compliant. Paperless Parts AI features are custom built for estimators, and capabilities and accuracy will continue to improve as the technology gets better. If you'd like to learn more, check us out at paperlessparts.com and request a demo today. Thanks.